Okay, welcome back. Before the break, we were dealing with 3D trigonometry problems. So we will continue with that. Let's look at our first example. Okay, in this example, it says the Great Pyramid of Giza is a square-based pyramid with a side length 230 meters and it's 139 meters high. So what they're telling us is we've got a prism and the base, the gray area, is square, which means every corner is a right angle. So that's a right angle, and that's a right angle, and so is that one. Okay, and they've given us that the sides are 230 meters, and that applies to all sides because it's a square-based pyramid. So all four sides will be equal. And they've given us one additional piece of information. They've given us the height. And the height is this line here. And they've given us the height to be 139 meters. Okay, so if you can picture the pyramid, and that's the height that's drawn there, that's drawn from the apex of the pyramid to the base of the pyramid. And this line that joins the height of the pyramid to the base will usually meet right at the center, and it will be also 90 degrees. Okay, and we'll discuss that a little further when we're doing the second question. The first question they ask us, though, is calculate the length of the diagonal of the base of the perimeter AC as shown. So the first question tells us they want us to calculate this length, the length of AC. And you can see it's going to be a pretty simple calculation because we have a right angle triangle ABC here. And we have the two sides, so we can probably just use Pythagoras to complete that one. The second one says, if you were to stand in one corner of the pyramid and walk up to the top of the pyramid, what angle would you be walking up at and how far would you have to walk? Okay, let's first answer the first question and we get to the B as soon as we're done with that. Okay, so to find AC, again, we did say it's going to be a right angle triangle. And specifically, it's going to be a right angle triangle with our two sides being 230 and 230. And it means we've got to apply Pythagoras, which is pretty simple. So AC squared, the hypotenuse will be the sum of the two sides squared. So 230 squared and 230 squared. We've got to add them together, and we're going to end up with AC squared is 105,800. And then we end up with AC being roughly around, sorry, I should have actually have a unit there. So it's roughly around 325,27 meters if we're rounding off to 2 decimal places. Okay, so that was pretty simple. Okay, let's get to the second question. And the second question was asking us, if we were to stand in one corner of the pyramid, so basically if we're standing here, and we walked up the pyramid like this, what angle would we be walking at? So they want us to calculate this angle here that's labeled theta. What angle will we walk in? So it's from the base of the pyramid, from the base of the pyramid up to this line that's joining A and M. And they're asking us how far we would have to walk and what is the angle. Okay, so let's begin by finding the angle. Remember, we've already found that AC is 325,27 meters. And we're going to need that because if the whole diagonal is 325 meters, that means this point here, N, will divide the line in half. So AN will equal to NC. And that's where we're going to begin our calculations, because if we look at the triangle that we're trying to find, it's this pink triangle here. So we're going to use this triangle, AMN, which is a right angle triangle. Here's our right angle. Remember, I showed you earlier, it's sitting there. And we can find AN. And because we have theta, and this is a right angle triangle, we only need 2 bits of information. So we have an opposite side, and we have this. If we find this adjacent side, then we can use our tangent function to solve for theta. So let's write that out. Okay, so here's our triangle. And remember, we have this height that's 139 meters. So we're going to calculate AN first. Remember, we said AN is going to be half of AC that we found earlier, and AC was 325,27 meters. We're going to divide that by 2, and now we have our value for AN. So AN is roughly equal to approximately 162 meters. Now, because we have both sides, we have an opposite side, and we have the adjacent side, we said we're going to use a tangent function So tangent of theta is equal to mn over an, and we're just going to plonk those values in there that we found. So 139 over the adjacent that we found. And using second function tan of our answer, we're going to end up with our angle theta being roughly equal to 40,5 degrees. So these calculations should be quite easy. Okay, so as you can see, the calculations themselves are not very difficult. It's just identifying what the 3D figure looks like and which part of the 3D plane you're working with. Okay, let's continue. Okay, here's our next example. In this example, bird stands at a point B on the ground. The angle of elevation to the top of the cliff from B is 38 degrees. So we're talking about the angle of elevation, so it's the angle from the horizontal upwards is 38 degrees. And because we're talking about the horizontal upwards, we're going to notice later that this angle is going to be a 90-degree angle. Okay, and Dan stands at D, which is 685 meters away from B. C is at a point at the base of the cliff. So because C is at a point at the base of the cliff, we can join those lines. And Dan estimates that the angle CDB is 42 degrees. So this angle between the cliff and B is 42 degrees. He wants to know what is the height of the cliff H rounded to 2 decimal places. So we need to find this. Okay, so this is a pretty simple 3D diagram because we only have 2 planes. We've got the horizontal plane, BCD, that's that one. And then we have the vertical plane, that's ABC. So ABC is a right angle triangle, which means we need to have 2 bits of information for ABC. As it stands, we only have the angle, so we cannot solve that triangle. But if you look at the triangle CDB, we've got 3 bits of information. We've got 2 angles and a side. Can you remember which rule we should use here? I'll let you think about that for a while. Okay, have you thought about which rule we can use? Okay, there's a bit of a problem here because we don't have a matching pair and we don't have side angle side either. But if you notice, we do have 2 angles, which means we can easily find this third angle here, and once we find that third angle, we will have a matching pair because we'll have an angle and its opposite side, which means then we can use the sine rule. So let's begin by finding angle DCB. So remember, it's going to be 180 minus 42 minus 63 degrees. So it's just going to be 75 degrees. So because this angle is just going to be 75 degrees, we can use the sine rule. And remember again, we're going to use the sine rule because we want to find BC. We need one more bit of information in this triangle to solve this triangle. Because if we find BC here, then we can use AC over CB. So we'll have the opposite and the adjacent sides of the right angle triangle. And then we can use tangent to solve for H. So back to our triangle BCD. We've got our pair and we need to find BC. So we're going to start off our equation with BC in the numerator. So using the sine rule, we're going to start off with BC in the numerator. So BC over the angle across from it, and across from BC, we've got 42. So BC over 42 must equal to 68.5 meters over the angle across it, and the angle across that side is 75 degrees. That's the one we just found. Okay, we've got to just rearrange this to get BC. So BC is equal to 68.5 times sine of 42 over sine of 75. And then it's pretty simple. We're going to just put this into our calculator. Let's just do that quickly. Okay, so we're going to say 68.5 times sine of 42, and that's got to be divided by sine of 75. So our answer is going to be 47,4523. Okay, and remember, because we want to find, oh, sorry, I haven't written the answer. Let me just call out my calculator again. Okay, we're going to keep that in our answer in our calculator, that 47,54523, because remember we're still continuing with the sum. So instead of rounding off and leaving the answer, we will continue with the answer with all the decimals on our calculator. Okay, then we said we're going to use tan of 38 to find the hypotenuse. And remember, tan of 38 is equal to h over BC. So tan of 38 is equal to h over BC. So, but remember, we're going to rearrange this so we can make h the subject of the formula. So h will equal to BC times tan of 38. And remember, this is the value we have in our calculator at the moment. So we just have to multiply that by, so there's our value in our calculator, our value for BC. And now we've got to multiply it by tan of 38 degrees to get our value for h. So our value for h is approximately 37,0738. Okay, so BC times tan of 38 is approximately equal to 37,0738. And remember now, because we've substituted that value for BC into the calculator, you could either have done it in one step, like this, or the way we did it earlier, and you're rounding off to 2 decimal places, so it's 37,07 meters. Okay, it's time for a quick air break. See you just after this.